Hi everyone. Our group number have Qirou, Liao, Yuan, Zhao, Ning, and Siyi. Today our topic is equilibrium. So, what is equilibrium? Our introduction. In a chemical reaction, chemical equilibrium is the state in which both reactants and products are present in concentration which have no fluctuation tendency to change with time. Usually, this state results when the forward reaction process is the same rate as the reverse reaction. The reaction rates of the forward and backward reaction are generally not zero, but equal. So there are no net change in the concentration of the reactants and the products. Such a state is known as the dynamic equilibrium. Each equilibrium reaction has a equilibrium context.
Characteristic reverse reaction has equilibrium. The forward reaction proceeds at the same rate as the reverse reaction. The moles reactant is equal to the product. Chemical equilibrium is a dynamic equilibrium. Although the number of moles are not changed, the substances are reacted and produced. When environment is changed, chemical equilibrium will change as well. The chemical equilibrium only exists in a closed system. There are no substances come or out. With the condition of the volume of gas, products are different for the volume of gas reactant. It arrives equilibrium when the total volume does not change anymore. With the condition of color of products are different for the color of reactant, the arrives equilibrium when the color of mixture does not change anymore. The reaction arrives equilibrium when energy not change anymore. The concentration of substances do not change anymore.
Hi, this is Ning. This is the most regular reaction form we've learned so far. A moles of molecule A plus B moles of molecule B. They react form C moles of molecule C plus D moles of molecule D. Put this reaction into the energy graph. A, B, C, D can be numbers of moles or the ratios of the molecules. The reactant is in the higher energy state, and then you have some activation energy. Finally, they got to the lower energy state. It looks like one-way direction, but actually, it didn't happen a lot in the real life. Some of these molecules have a big amount of kinetic energy. They can pass the activation energy and then go back to the reactant side. So it's a two-way reaction. When the rate going in the forward direction is equal to the rate going in the reverse direction, the reaction reaches equilibrium. In a word, in the reversible reaction, reactants are converted into products and back again. In over time, eventually they reach equilibrium. K is equilibrium value, or we can call it equilibrium constant. It's a way to measure when we reach equilibrium. Do we have way more reactant or way more product?
This is Angelia. Now I talk about how to calculate the equilibrium constants. Firstly, we need to take the concentration of each product and multiply them by each other. Then, listen them to the mole relations that you are taking. So, in this case, it will be the concentration of BC raised to the lowercase c power and the concentration of BD raised to the lower custody power and divided by the concentrations of the reactants, capital A to the lowercase a power, capital B to the lowercase b power. So by these calculations, we can get the equilibrium constant. When the reaction not change anymore, the equilibrium constant will not change. That's all.
And still have 3 references we found in YouTube and some websites. So if you're interested about our topic, you can go to those websites to check. And thank you for your watch.